All right, I'm going to jump right to the rotation because I think that's the one that's the hardest for people. Um, I will probably go back and do the two translations, but I'm going to do this rotation real quick. So first of all, the main idea you need to absolutely remember is any of these, when I rotate them around the center, they have to, any point here has to follow a circular path somewhere, okay? If I'm rotating around the circle, G prime ends up somewhere along here. In the same way, H prime ends up somewhere, if I can get the point right, somewhere along this point right here, further away, and then I prime has to end along this circle right here. So no matter how far I rotate it, it's got to end up on that circle. And then the other thing is they should all move the same amount. Now, I is going to end up out along here because that's my my angle of rotation. That J is nothing. That J is simply to indicate I'm doing angle IXJ. It's there a little bit to confuse you, but it's not. So we know I prime is right there. We are done right there. And then we have a choice. We can either figure out what this angle is and duplicate it and put the same angle from G to X probably out here somewhere. So G is probably going to end up there somewhere. And I could do that same angle from H to X, and so that angle's about here. It's almost 90 degrees. So we know H is going to end up out here somewhere. So this is kind of my target for H, and this is kind of my target for G. And I could certainly do that. But the other way we talked about doing it in class, which is what we call the Austin method, is basically as long as I kind of know where these are going to land, I can just measure these out and make sure they land in those relative spots. The only danger of doing it this way, it is possible to accidentally get your J over here or get your H back there because there are two places that these measurements that I'm going to do line up. But so I'm going to measure how far is it from I to G. So from I to G, I know it's going to be this far. And so it's right there. And I'm going to transfer that measure over here. And so it's going to end up roughly where I thought it would. Now the only problem with this method too is, especially depending on the shape of your triangle, it gets a little hard to figure out exactly where this is. But I think my G prime is roughly there. And then my H prime is going to be this big. Right there. And I can come back and do this. And once again, this is the problem. If I don't recognize that I'm going to land over here, I could accidentally put H up here. This is not the correct place to H. It will not look right, and that's a clue. So that's there. So there's my H prime. And once I draw this thing in, if it doesn't look quite right, I might want to go back and remeasure between H and G and make sure that spacing is right. For me, it felt that H point felt a little cleaner than my G point, so I'm going to double check here. Yeah, my G is a little further back there. I'm gonna remeasure this all because I'm not quite happy with where my G landed. So I'm going to remeasure this. It's close, but if I can guarantee right now if I drew this in, it's not going to quite look right. Okay, from there to there, get right on the point there. Oh, yeah, it's closer to right here. It's a little hard to tell. I'm going to put it there and remeasure. Like I said, that's the one problem. And if I actually put the angles in, I'd probably have a better chance of getting it right. And I'm going to remeasure this one more time. From there to there. That's closer. It still seems a little off. Let's draw it in and see what it looks like. Get it so you can actually see it. Okay, so that's there. And finally, so there we go. And like I said, that's pretty close. I think maybe still this side may not be quite long enough. But that's the basic idea. And like I said, if you wanted to go in and just to go backwards, what we could have done to begin with is we could have said, oh, from here to here, there is some angle that has to be the same as this, and then I could duplicate that angle either with by measuring with a compass or by using a protractor. If I actually measure with a compass, you could stop it now if you got the idea. I don't want to confuse you, but the other way I could have done this is I could say, oh, from here to here, it's this far, so from that other ray to here, it's this far, and then I extend this on out. Like I said, this would be if I had done it the other method. I'm kind of going in and filling in the other method now, and that lines up pretty well. So that was pretty good. And then I could do the same here. This is going to be a real mess, so don't let it confuse you. The original method we did was fine. But once again, I know from that line, if these two are this far apart, and I just transfer that measurement over here, there should be another line that extends from there to here. And maybe I'll color code these here. And that was pretty good. So basically kind of this line going down goes out to here, and I'll do a little X's on this one. This line going down goes out to here. You can kind of follow those out. So from here to here, from here to here, all three of those angles are the same. And that's the basic idea, but our original was fine.